Dear students, already we have discussed some basic things of system of equations in the chapter of linear algebra in our two previous videos. Today we will discuss the most awaited things of the linear algebra, that is the Gauss elimination. And in Gauss elimination process we solve a system of equations. But before going to discuss how we solve the solution of equations by Gauss elimination, let us know the rules that how we do the problem in Gauss eliminations. So working rule for Gauss elimination. Okay, you see the rule 1. Rule 1 says what we will do. First you write the corresponding augmented matrix. Okay, you know what is augmented matrix, and when we write the augmented matrix, then observe whether A11, that means the first row first column element, is 0 or not. If it is not 0, then it is well and good. But if it is 0, then what we have to do? We have to exchange the row 1 with any other row whose first element is not 0. Okay. Then come to the second step. In second step, what we do? In step 1, we have arranged as if A11, the first row first column element is not 0. Then you consider this A11 as the pivot element. Right? Then below that A11, try to make all the elements below A11 as 0 with the suitable row operations with row 1. That means when we will do the row operation, we will take the help of row 1 to make all the elements below A11 as 0. Right? When we make all the elements below A11 as 0 with row operation, that row operations will be applied to the corresponding element of the entire row. Okay. How we are doing it, we will come across along the problems. Then the step 3. Like step 2, we do the step 3 by considering A22 as the pivot element. When we consider A22 as the pivot element, in that case we will make all the elements below A22 as 0 again by the suitable row operations, but here we will apply the row 2. In this case, when we are considering A11 as the pivot, we will use row 1. When we will consider A22 as the pivot, we will use row 2. Okay, proceeding in the similar manner, we will go up to the last such that we will find a echelon form of matrix. Echelon form of matrix means if you consider any two adjacent rows, then the top row will have less number of 0 from the beginning than the next row. Okay, this is the echelon form of matrix. And once we get the echelon form of matrix, then we write the final row reduced echelon form matrix in equation form, and by backward substitution we get the result. Okay, so this is the law. You can keep the screenshot of this law, and then we will apply this law to some specific examples to solve the equations. Now we will solve the system of equations with this example. X plus y plus z equal to 6, 2x minus y plus 3z equal to 9, and 3x plus 2y minus z equal to 4. Okay, when simultaneously we consider these three equations, that constitutes a system of equations. You see how we solve this system of equations using Gauss elimination process. So step 1. Step 1, as per our law, we write the augmented matrix. So augmented matrix is augmented matrix, that is 1 1 1 6 2 minus 1 3 9 3 2 minus 1 4. This is the augmented matrix. Okay, in this augmented matrix we observe this A11 whether it is 0 or not. This is not 0, so no problem. If in a problem this will be 0, but we will find other row where the first element are not 0, then we will exchange this row with any other row. But for this problem, that is not the case because this is non-zero. Okay. Then step 2, we do the row operations. See how we do it. So when we will come from step 1 to step 2, we will not change row 1, that is 1 1 1 6, and we will change row 2 and row 3, means this is the pivot element and we will make these 2 as 0. So just first you write 0 0, then you think how can we make these 2 as 0 with the help of row 1. So here I am writing the law. We are changing row 2. How we are changing row 2? With the help of row 1, that is minus 2. So row 2 is minus 2 row 1 plus row 2, and row 3 is minus 3 row 1 plus row 3. You see, we are taking the help of row 1. So by that we are getting minus 3 1 minus 3 minus 1 minus 4 minus 14. Okay, then step 3. In step 3 what we do, you see, now this is our pivot element because this is A22, then we will make this as 0. That means we will not change row 1, we will not change row 2, we will change only row 3. How you do it? That is 1 1 1 6 0 minus 3 1 minus 3 0. Then we have to make this one as 0, just we write it as 0, and we think how can we make it 0. So that is row 3. How can we make it 0? This is minus 3, this is 1. If we multiply 1 by 3 to this row, that is 1 minus 1 by 3, we multiply minus 1 by 3 to row 2 and we add it to row 3. Okay, so minus 1 by 3 into minus 3, that gives 1, and we add this is 0. So we will apply this law to the entire row. So that gives 0, this is minus 13 by 3 and this is minus 13. Okay, now our process is over, because for the third row we may consider this as the pivot, but below that there is no any other element, so this is the last, and this matrix is now the echelon form of matrix. Because you see, if we consider this two row, first row doesn't contain 0 from the beginning, so this contains 1 row. If we consider these two row, this row contains 1 0, next row contains more than that, it contains 1 0, it contains 2 zeros. So that is the idea about the echelon form. And if we get the echelon form, then we write its equation. Then its corresponding equations will be, that is the step 4, that is x plus y plus z is equal to 6 minus 3y plus z is equal to minus 3 and minus 13z by 3 is equal to minus 13. Okay, so by backward substitution, so now minus 13z by 3 is equal to minus 13 implies z is equal to 3. Then put this value z in second equations. So again minus 3y plus z is equal to minus 3 implies minus 3y plus z means plus 3 is equal to minus 3. So that implies minus 3y is equal to minus 6. That implies y is equal to 2. Now you see, we have taken this system of equations, and after successive steps of row operations, this is our final step from which we get the solutions, and this structure is called as the row reduced echelon form, right? And what is the conclusion we get? We get, if after row operations the number of non-zero rows, you see how many non-zero rows are this? This is one non-zero row, this is one non-zero row, this is one non-zero row. If number of non-zero rows equal to number of unknowns, what are the unknowns? X is one unknown, y is one unknown, z is one unknown. That means there are 3 non-zero rows and here there are 3 unknowns. If that are same, then we conclude that this system of equations will have unique solutions. Okay, unique solutions means it will have only one solutions. Okay, so this is the conclusion from the example 1. Now we will consider other examples where these conditions will not appear. Okay, now we will consider the second example for Gauss eliminations. Here we have considered 4 equations. First equation is x plus y plus z equal to 6. Second equation is 2x plus y minus z equal to 1. Third equation is 3x plus 2y plus 2z equal to 13. 4x plus 2y minus 2z equal to 3 is the fourth equations. And from this set of equations we construct our first step, that is the augmented matrix. Okay, for first equations, that is 1 1 1 6, this 1 1 1 is the coefficients. For second equations, 2x plus y minus z equal to 1, this is the line, 2 1 minus 1 1. This is the third equations, corresponding line is 3 2 2 13. This is the fourth equation, the corresponding line is 4 2 minus 2 3. Okay, and once we formulate this coefficient matrix, then we will go for row operations. Okay, with the aim that we will consider this one as the pivot element and we will try to make below all the elements as 0. You see in second step how we are doing it. As we will change the elements below pivot, so we will not change row 1. So just we copy the row 1 1 1 1 6 from here. How this is becoming 0 minus 1 minus 3 minus 11? You look at this previous matrix and this is the law. How we are changing row 2? Row 2 is formed by the law minus 2 r1 plus r2, and this idea you have to think. This is 2, how can we make this 0? If we multiply minus 2 this one, minus 2 into 1 becomes minus 2 and minus 2 plus 2 becomes 0. So that is why we have designed this formula. Okay, and this law will be applicable to all the elements of the second row. So minus 2 into 1 minus 2 plus 2 0, minus 2 into 1 minus 2 plus 1 minus 1, minus 2 into 1 minus 2 plus of this, that is minus 3, minus 2 into 6, that is minus 12 plus 1, that is minus 11. So this is second row. Then come to third row, row 3. Row 3 we have made the law minus 3 r1 plus r3. That means in row 1 we will multiply minus 3 and that result will be added to row 3. Minus 3 into 1 minus 3 plus 3 0, it is 0. Minus 3 1 minus 3 plus 2, that is minus 1. Minus 3 1 minus 3 plus 2, that is minus 1. Minus 3 into 6 minus 18 plus 13, that is minus 5. Okay, similarly come to the row 4. Row 4 law we have made minus 4 r1 plus r4, means you multiply minus 4 to row 1 and the result you add to this. So minus 4 into 1, that is minus 4 plus 4, that is 0. Minus 4 into 1 minus 4 plus 2, that is minus 2 here. Minus 4 into 1 minus 4, this is minus 2. If we add that 2, that is minus 6. Minus 4 into 6, that is minus 24. Add that to 3, minus 24 plus 3, that is minus 21. So second step is over. Okay, now in second step this minus 1 will be our pivot and we will try to make these 2 as a 0 in the step 3. Okay, now you come to step 3. When we will come to step 3, we will not change step row 1 and row 2. Okay, so just we have copied it from this. So 1 1 1 6 1 1 1 6 we have copied. 0 minus 1 minus 3 minus 11, 0 minus 1 minus 3 minus. So these two just we have copied in step 2. Now you come to the row 3, how we have made it. So this row will be made from the separations, second steps. Okay, what is the law? Row 3 is minus r2 plus r3. So here in row 2 you multiply minus 1 and then add that result to this. So we are multiplying minus 1 into minus 1, that is plus 1, and add this, so that becomes 0. Then multiply minus 1 to this, minus 1 into minus 3, that is 3, then add this 3 to the minus 1, that is 3 minus 1, that is 2. Multiply minus 1 to this, minus 1 into minus 11, that is 11, add this to this, 11 minus 5, that is 6. Similarly come for row 4. So how row 4 is made? Minus 2 into r2, means we will multiply r2 with minus 2. So minus 2, because all are 0, you come from this. So you multiply minus 2 to this, minus 2 into minus 1, that becomes 1. Then add that to this, sorry, minus 2 into minus 1 becomes 2 and this minus 2 becomes 0. Okay, then come to this, minus 3 into minus 2, that becomes 6 and this is minus 6. If you add, that becomes 0. Then come to this, you multiply minus 2 this, minus 11 into minus 2, that is 22. That 22 is added to this, that gives 1. Okay. Now you see, this is our row echelon form of matrix. So why? You see, first row the starting there is no 0, second row starting only 1 0, third row starting more than 1 0, that is 2 0, third row that is more than 2 0, that is 3 0. So this is row echelon form. And as this is the row echelon form, now you count what are the number of non-zero rows. So you see here, the in coefficient matrix we get, this is the 0 row and its corresponding element is 1. From that we get a conclusion. If after row reduction we get a 0 row in the coefficient matrix and its corresponding element is non-zero, then that system of equation cannot have solutions. Okay, so this is the conclusion. Again I am repeating, after simplification, if we are getting a 0 row in the coefficient matrix part, because this is our coefficient matrix part, okay, wherever it may be here or anything, anywhere, if we are getting a 0 row in the coefficient matrix but its a corresponding element is non-zero, then the system of equations can have no solutions. Now we will consider the third example, that is, we solve this x plus y plus z equal to 6, 2x plus y minus z equal to 1, 3x plus 2y plus 2z equal to 13 and 4x plus 2y minus 2z equal to 2. From this system of equations, for these equations, this is our matrix row line. For this equation, this is our second line. For this equation, this is our third line. For this equation, this is our fourth line. So by this we are constitute the coefficient matrix. Then in this coefficient matrix, this is our pivot element, and by using that we will make this as 0. Okay, so from step 1 we are making the step 2. You see, I have written the law. This is row 2 is equal to 2r1 minus r2, means in this row, in row 1 we are multiplying 2 and that result is subtracted by this. So 2 into 1 2 minus 2, that is 0, 2 into 1 2 minus 1, that is 1, 2 into 1 2 minus of minus 1, that is plus 1, that is 3. Okay, similar 2 into 6 12 minus 1 11. Like that we are forming r3 equal to 3r1 minus r3. So we multiply 3 to this and then subtract this. So 3 into 1 3 minus 3 0, 3 into 1 3 minus 2, that is 1, 3 into 1 3 minus 2, that is 1, 3 into 6 18 minus 13, that is 3 into 6 18 minus 13, oh that is 5. Okay, similarly come to row 4. Row 4 loss is 4r1 minus r4. So we are multiplying this 4 into 1 4 minus 4, that is 0, 4 into 1 4 minus 2, that is 2, 4 into 1 4 minus of minus, that is plus 2, that is 6, 4 into 6, that is 24 minus 2, that is 22. So we form the second steps. Then you come to the third step. In third step we use row 2, means row 1 and row 2 will not be changed, just we copy row 1 and row 2. Okay, and using row 2 we are changing row 3 and row 4. So how we get row 3? Row 3 is minus r2 plus r3, means we are multiplying minus to this. In this row we will multiply minus and we will add to this, minus 1 into 1 minus 1 plus 1, that is 0, minus 1 into 3 minus 3 plus 1, that is minus 2, minus 1 into 11, that is minus 11 plus 5, that is minus 6. Then you come to row 4. Row 4 is minus 2r2 plus r4. So we are multiplying minus 2 to row 2 and the result is added to row 4. So minus 2 into row 2. So we multiply minus 2 this, minus 2 into 1 minus 2 plus 2, that is 0. minus 2 into 3 minus 6 plus 6 that is 0, minus 2 into 11 minus 22 plus 22 that is 0. Okay, so this is our third step. Now you see this is the row echelon form, but here we get one row which is completely 0. Okay, so if you compare the problem with the previous one, in the previous example, in example 2 we have found that coefficient part is 0 but here non-zero, so that indicates the solution does not exist. But here all are 0. If all are 0, we have to think with some idea, some trick. See, if we are getting a complete 0 row, then look at how many non-zero rows are there. How many non-zero are there? This is non-zero row, this is non-zero row, this is non-zero row. So we are having 3 non-zero rows. But how many unknowns are there? X is one unknown, Y is one unknown, Z is one unknown. So we are having 3 unknowns and 3 non-zero rows. Means now this system is equivalent to the example 1. Because in example 1 we have considered a case where to the last we have found out the row echelon form which contains 3 non-zero row with 3 unknowns. Similarly here we get 3 non-zero rows with 3 unknowns. Means this type of problems can give unique solutions. So when number of non-zero rows equal to number of unknowns, it gives unique solutions. So as it can give unique solutions, we solve it. So the last line is this. This value minus 2 is for the third column means z, so we write minus 2z equal to minus 6, that gives z equal to 3. Then we put for the second equation. So this line says y, this variable for y, this variable for z, so we write y plus 3z, this is y plus 3z because this is 3, y plus 3z equal to 11. That implies y plus what is z? Z is 3, so y plus 3 into 3 9. Okay, so this will be 11 minus 9. Okay, the result will be 2. Okay, then x plus y plus z, we get y as 2, so x plus 2 plus 3 is equal to 6. That gives x is equal to 6 minus 5, that is 1. Okay, so this is the third example which mainly gives the idea that if we get a complete 0 row, that is a special case. Sometimes it may give unique solutions and we will come across another type of problem which will indicate that will give us infinite solution. We will come across. Okay, so this example gives the idea that it gives the unique solutions. We will come to the next example. Now we consider the last example, that is example 4. This is the system of equations x plus y plus z equal to 6, 2x plus y minus z equal to 1, 3x plus 2y plus 3z equal to 18 and 4x plus 2y minus 2z equal to 2. Then from this system of equations, this is our augmented matrix. First equation, x plus y plus z equal to 6, the line is 1 1 1 6. Second equation, 2x plus y minus z equal to 1, the line is 2 1 minus 1 1. Third equation, 3x plus 2y plus 3z 18, that is 3 3 3 18. Fourth equation, 4x plus 2y minus 2z 2, 4 2 minus 2 2. So this is our augmented matrix, right? Then from this step 1 we create step 2. This is our pivot element and we have to make this as 0. Okay, and this is the law. Okay, so by this law, row 2, row 3, row 4 we have changed. Okay, then we go for the step 3. Step 3, just we have exchanged row 3 and row 4 because in this step we get row 3 as 0 and row 4 as non-zero. So we bring this non-zero row to the top and 0 row to the right. So in step 3 just we have added, this is one additional step for simplification. So if we are getting 0 row, we keep it to the last. Then using row 2, we convert row 3 by this law. Now by this operation, we get the third row is also 0. Now in this step, we found one interesting thing. We get two 0 rows, right? The coefficient part is 0 as well as the augmented part is 0. So we get 2 non-zeros. So as we get 2 non-zeros, and how many unknowns are there? 3. If the number of non-zero rows is less than number of unknowns, here number of non-zero rows is 2 and number of unknowns is 3, so 2 is less than 3, then we say it gives infinite solutions, right? How it gives infinite solutions, that I have explained. You see, from this you write the equations: x plus y plus z equal to 6. This is the equations. This is -1 minus 3 equal to -11. If we multiply minus, that gives y plus 3z equal to 11. Okay. And here we consider any one of the variable. Y plus 3z is 11. We consider any one variable as a, say with z equal to a. If we substitute z equal to a, then y gives 11 minus 3a. We get y and z in terms of a. Then putting the value of y and z in the first equation, we get x is equal to -5 plus 2a. Now we get the value of z as a, value of y as 11 minus 3a, and value of x as -5 plus 2a. All x, y, z are given in terms of a. Now it is our choice that whatever value for a we decide, accordingly we will get the value of x, y, z. If we consider a as 1, we will get a set of value. If we consider a as 2, we will get another set of values like this. That means for infinite values of a, we will have infinite triplet of x, y, z. So this example says if number of non-zero rows is less than number of unknowns, then that gives infinite number of solutions. So by discussing all these 4 types of examples, at least you will have some clear idea that how you will work out the Gauss elimination process to solve the equations, and after getting the row echelon form, what the conclusion you will draw, it is clear from the different examples. Thank you.